Okay guys, we're in Advanced Math Trig, Mod 7. Today is Thursday, April 23rd. So in the top left corner of your notes, Thursday, 4/23/20. Same title as yesterday. If you remember, we had a worksheet on exponential equations. So same title today, exponential equations. Every equation we're going to solve, just like yesterday, is going to have a missing exponent somewhere involved in it. The worksheet we were doing yesterday, I'll just put it under here real quick and remember, it was 1 to 32 questions. There were 32 problems on that. It was attached to your Schoology. Hopefully you were able to print that out and then utilize it. At least call it up on your screen and look at all the questions. We did 1 to 15 odd in our notes yesterday. Your homework was 2 to 16 even. Most of you did really well on that. Continuing that worksheet today, it's going to get a little tougher, so stay with me, pay attention, and think with me through the steps. Our goal today is to do 17, 19, 21, and 23 on the front. 25, 27, 29, and 31 on the back. So these will be the 8 questions I attack and we try to solve correctly in our notes. Your homework will be, 18 to 32 even. Again, use that same worksheet that we had yesterday. It's attached to Schoology. And your homework, 18 to 32 even, will be due tomorrow on, Friday the 24th at noon. And try those 8 problems on your own. Okay, now they mimic and are very similar to the 8 I'm about to do. So I'll go through this as quick as I can, so stay with me, but think with me. Don't just copy the steps here, because I'm going to explain the steps and the thought process so you can do the same thing when you try these on your own. Okay? Number 17 looks like this: 3 parentheses 1 plus e to the 2x equals 4. Just like yesterday, my original thought, since this is an equation with a missing exponent, is to get that e to the 2x thing by itself, right? Oh, well, if you look at the problem, there's a parenthesis involved. So obviously that's a dot-connected 3. My first thought is, why not get rid of that 3? We don't want it over there. It's in the way. I don't need to distribute and clutter up this side. Why not divide both sides by 3? Those 3's would cancel. I'd have 1 plus e to the 2x equals, obviously, 4/3 is what? 1.33333, right? So I'm just going to put 1.3 with a bar over it as a repeating decimal. Again, our goal is to get e to the 2x by itself. I'm going to subtract over the 1. Those 1's would cancel. I've got e to the 2x equals, and of course, 1.33333 minus 1 is 0.3333333. Oh, well, now that I've successfully gotten the base and the exponent by itself, any equation that has a missing exponent, right, I'm going to solve it by logging both sides. And again, for right now, we can see the base is e, so I'm going to have to use natural logs, and I'm going to natural log both sides. Whatever I do to one side, I do to the other. So it's ln of e to the, and just like yesterday, my exponent here is 2x. I'm not going to write it up there because you're going to take the exponent and move it out in front anyway, right? Remember the product rule. So the 2x goes in front. Equals, remember, if I ln the left, I got to ln the right. Some of you forgot to ln the other side. ln of 0.33333. ln e, if I ever see it, is irrelevant because, again, it's equal to the number 1. So, of course, to finish getting x by itself, I'm going to divide by 2. So on my calculator, make sure your calculator is out. I'm going to hit ln 0.3333333, just type in several of them, hit enter, then push divided by 2, enter, and I'm getting negative 0.549 to the nearest 3 places, and I did it, okay? Number 2, 400 over 1 plus e to the negative x equals 200. Put that on your paper as number 19 on our worksheet. Now I'm looking at this. You should, I hope, be thinking the same thing here. Hey guys, isn't that 200, since it's a whole number, understood to be over 1? And I'm pointing that out because my initial thought or instinct is, hey, that's a proportion, right? A fraction equal to a fraction. Wouldn't your attack plan be cross multiply here? So if I'm going to take 200 times that guy there, now just like that last problem we did, I'm going to leave the 200 in front of the thing I'm timesing it by. I'm taking 200 times 1 plus e to the negative x equals, and then of course when I cross multiply the other direction, you get what? 400. Oh, so just like on that last problem, since that 200's dot connected, I'm going to divide by the 200 and get rid of it. They cancel. Don't even need my calculator yet. 1 plus e to the negative x equals, what is that? 2, right? 400 divided by 200. Of course, I'm trying to get the e by itself, so I'm going to subtract over my 1. I end up with e to the negative x equals 1. Okay, freeze. See, I've done these a long time. My instinct is telling me I don't need to do anything else to answer this question. Remember, how many times have we said this? Any base, no matter what it is, if you raise it to the what? 0 power. Anything raised to the 0 power always gives you 1, no matter what. Oh, so I can just look at this and tell that my missing x would be 0. Okay? If you didn't notice that, and you would have ln to both sides and put the power in front and crossed out the ln of e, just like we did on the last one, it still would have worked. But why not save time and jump straight to that step? Okay? Number 21. For the first time and for the rest of this paper, now we've got a base involved that's not an e. Okay? So what's the only difference? Well, the good news here, of course, the base and the exponent are already by themselves. So to solve for the missing exponent, I'm going to what? Log both sides. But now the base is not an e, is it? Since it's not an e, I don't need to natural log both sides. I'm going to LOG. I'm going to log both sides. So I'm going to write log of 10 to the x equals the log of 42. Take that x, put it out in front. I've got x log 10 equals log 42. Now the difference, guys. Remember, usually we had an ln of e at this point, right? And ln of e is just the number 1, so we usually crossed it out and ignored it. Now, because this x is dot connected to the log of some number, to get that x by itself, we need to divide by the log of 10. Those would cancel. So my calculator is going to do the work for me. Again, my advice, do not type all that in at one time. If you forget the parentheses on the 42, you're going to mess up your answer. So my advice, hit log 42, hit enter. Now that you've entered it, now divide by log 10, hit enter. And I'm getting 1.623. Yes, again, everything to the nearest 3 places. And finally, the last one on the front, number 23. I've got a missing exponent. When in doubt, log it out. It's not an e. So since the base is not an e, I don't want to natural log it. I'm going to log both sides. So the log of 3 to the, now you might as well save a step. Why write 2x as the exponent when that exponent's going to get moved out in front anyway? Agreed? Equals, now remember, I'm logging both sides, so that's the log of 80. Just like on that last problem, since there's a dot connection, I'm going to divide by the log of 3 to get rid of it. Those would cancel. This is easy. I get 2x equals, you're typing log 80, hitting enter, divided by log 3, enter. I'm getting 989. Now notice that's not my answer because this says 2x, doesn't it? So I'm going to divide by 2 now. So bottom line is that number that's still on your calculator screen, push divided by 2. Guys, go ahead and do all this on your calculator with me as if you're in class following right along here. And it looks like it's 1.994. To the most exact specific answer we can get to the nearest three places. Okay? On the back, number 25. Again, I've got a base raised to a yucky exponent. So what? That doesn't change the procedure, does it? I'm going to log both sides. So I've got the log of 5 to the... Now, just like yesterday, there was one like this. Let's think about this for a minute. Since that says negative x over 2, that x is understood to have a 1 in front of it. Isn't that really negative 1/2 x? So in my mind, it's easier to write negative 0.5x equals the log of 0.20. So I logged both sides. I'm taking that exponent and moving it out in front. Agreed? And then we would divide by the log of 5. So I'm going to save again a step here on our paper. If the exponent gets moved to the front, I've got negative 0.5x equals, now on that side we had the log of 0.20, but it would be being divided by the log of 5. Agreed? I'm just saving a step and doing that right now. So I've got negative 0.5x equals, take my calculator, I hit log 0.20, hit enter, divided by log 5, enter. I get negative 1 exactly. How about that? To get that x by itself, we divide by negative 0.5, right? Those cancel. And if I take that negative 1 and it's on my screen and I divide it by negative 0.5, I get exactly, how about that? Positive 2. Who would have thunk that's the missing number in that problem? My missing exponent. Okay? 27. There's a 1/3 in front of the 10 to the 2x equals 12. Now, just because it's a dot connected 1/3, I guess I could divide by 1/3. Wouldn't it be easier to just multiply both sides by 3? Everybody agree? If I got 1/3 and I'm timesing it by 3, the 3's would cancel. So I just have 10 to the 2x equals, what, 36? And we're right back to where we've been on the last few problems. I'm going to log both sides. I've got log of 10 to the 2x. I'll move that exponent in front. Equals log 36. Don't forget to log the right side. Divide by log 10 on both sides. Log 10's cancel. 2x equals, so I'm going to type log 36, enter, divided by log 10, enter, and I'm getting 1.556. Now I'm just leaving that decimal on my screen because I know I've got to divide that by 2. So back to my calculator, pushing divide by 2. It looks like 0.778 is our missing value there. And by the way, I'm going to show you reasons we need to know how to do this and find missing exponents. The last part of this chapter is application driven, where we show you real life formulas, growth and decay and compound interest out in the real world, where missing exponents are utilized to solve for missing parts of important equations. Okay? All right, last two. Number 29 looks like this. Pretty obvious first step, right? Again, calmly look at this and think your way through. Since that's a dot connected 3, I'm dividing both sides by 3. Those cancel. I get 5 to the x minus 1 equals 7, right? So far, so good. I'm going to what? Log both sides. So I've got the log of 5 to the, okay, freeze. Think with me here. My exponent is x minus 1, and that whole thing is getting moved to the front of this problem. Guys, when I take that exponent and move it to the front, don't write it like that without parentheses. That looks like x minus 1 log 5. That entire exponent moved to the front, so it's x minus 1 that got moved and is dot connected to the log of 5, okay? Equals log 7. Because that is a dot connection, I can still divide by the log of 5. Those cancel. I have x minus 1 equals, go to my calculator, log 7, enter, divided by log 5, enter. I'm getting 1.209. Now to get that x by itself, don't we just plus over the 1? And we did it. Wasn't as bad as it looked. 1.209 plus 1 gives me what? 2.209. And I solved that exponential equation. And then kind of our grand finale on exponential equations here, number 31. Both values have exponents that are missing. It'd be really tough to even look at this problem and take an intelligent guess as to what the missing number is. Thank goodness we know. I hope the proper steps. Wouldn't our brains think, I've got a missing exponent on the left and a missing exponent on the right, so I still need to attack this by what? Logging both sides. So I'm going to put the log of 5 to the x plus 2 that I'll move again out in front with a parenthesis equals, and then I log that side. I'd have the log of 3 raised to the what? 2x minus 1 power, that would get placed outside. Okay, now you got to decide how you're going to handle this. Remember on that last problem how because that was a dot connection, I was able to divide by the log of 5? I'm going to follow with that idea since we did it on the last one and get rid of it on this. So at least on the left, we've got x plus 2. Agreed? Over there, now careful, there's still a dot connection in between there. So I'm still taking the log of 3 and dividing it by the log of 5 and creating some number that'll be next to the dot connected parenthesis. Are you okay there? So you're still going to push on your calculator log 3, enter, divided by log 5, enter. I'm getting 0.6826. So actually I've got 2x minus 1, and this log 3 divided by log 5 is 0.683. So now notice that ugly decimal has to get distributed on that right side. That's what makes this one kind of our grand finale. So I got x plus 2 equals, if I take 0.683 and times it by 2x, now let's see, 0.683 times 2, I get 1.366x minus, and then distribute it to the 1, of course, that'll be minus 0.683. Do you agree now? I've got an x on the left and an x on the right, so this 1x is going to get subtracted over to that side. So if I minus over a 1x, wouldn't that be 0.366x? And on that side, notice I had a 2, but I'm going to add over the 0.683, aren't I? So if I add that over, that's 2.683. So as ugly as that is at this point, to get that x by itself, which has been my goal all along, divide by the 0.366. Those would cancel. And so I'm pushing 2.683 divided by 0.366. Enter. And it looks like 7.331 to the nearest 3 places. Wow, is the answer to that one. Okay? So that wraps up day 2. A lot of different types of exponential equations. Let's see if you can really get good at that. You're going to approach your homework assignment as if it was a little 8-question quiz. You get a point for each one you can get right. And I'll give you a point for trying the whole thing and a point for using the right process. So guys, this will be a 10-point assignment. But bottom line is your grades are going to really depend on how well you can work these out. Take your time, follow your steps, trust your calculator, and give me answers to the nearest 3 places for, what is it, 18 to 32 even. 18 to 32 even on that worksheet that's attached to your Schoology. You try those 8 problems. Again, since today is Thursday the 23rd, those 8 are due tomorrow on Friday the 24th. Okay? Great job. We'll see you then.